This is Maths Demystified. Today we shall be dealing with the formulas for calculating the area of circle, perimeter of a circle, area of sector of a circle, perimeter of the sector of a circle, area of segment of a circle, and the perimeter of the segment of a circle. We shall start with the formula for calculating the area of a circle. In one of my previous videos, I explained that when we hear the word area, it means the inner part of the object we are dealing with. So the shaded portion you have in this circle is the area of the circle. So for us to find the area of this circle, we simply use pi r square. Where pi will be given as 22/7, or it could be given as 3.142, and r is the radius of the circle. If this is center O, the radius is the straight line drawn from the center touching the circumference. So this is the radius. And the formula for calculating the area is pi r square. Next, let's look at the formula for calculating the area of a sector. The sector of a circle is the part shaded, and you will see that this sector I'm dealing with is a fraction of the circle. This is the whole circle. So the sector is a fraction of the circle. What do I mean? Everything in a circle is also in a sector. In a circle, there is radius. In a sector, there is radius. In a circle, we have angle. The angle at the center there is 360, whereas the angle in a sector is not up to 360. That's why I represented it with theta. For example, if you have malaria and you go to the hospital and they want to run a test, they will take a fraction of your blood. They won't take the whole blood. And whatever result they get from the sample, they will conclude that is what is wrong with you. Similarly, the area of a sector is also a fraction of the area of the circle. So, to find the area of the sector, it will have the same elements of the area of a circle, but because it's not complete, we'll now use theta over 360. The theta we have here shows that it is not a complete circle. If it's a complete circle, it will be 360. So the theta we have here simply shows is a fraction of 360. So for us to be able to find the area of the sector, we only add the fraction of the 360, then we have pi r square. As simple as that. Let's consider how to find the area of the segment of a circle. The shaded portion is the segment of the circle, and if you look properly, you will see that everything here is a sector, and the upper part here is a triangle. I want you to note that anytime you are asked to find the area of a shaded portion of a diagram, you find the area of the whole diagram as big as it is, then you subtract the area of the part that is not shaded. So if you look at this diagram, you discover that the whole diagram is a sector. For us to be able to find the area of this shaded portion, which happens to be an area of a segment, you find the area of the whole sector, then subtract the area of this triangle. In one of the previous videos, I explained to us how to find the area of different types of triangles, and you see that this is one of the types of triangles we discussed there. This is the kind of triangles I told you that is like a V shape with an included angle. So we discussed there that the formula for finding the area of this type of triangle will be half AB sine the included angle. So for us to find the area of this segment, we use the area of the sector, which happens to be theta over 360 pi r square. Then we subtract the area of this triangle, which is half AB. In this case, they happen to be the same thing. That will be r square, then sine the included angle theta. If we're not given the included angle and we're given all the three sides, you go back to the previous video and check the formula to use. So, in summary, if you want to find the area of a circle, you use area equals pi r squared. And if you want to find the area of the sector of a circle, you use area equals theta over 360 pi r squared, where the theta is the angle given to you. And lastly, if you are to find the area of the segment of a circle, which happens to be this place, you use area of the sector minus area of the triangle that is given to you. In this case, theta over 360 pi r squared minus half r squared sine theta. I want us to consider the formulas for calculating the perimeter of a circle, the perimeter of a sector of a circle, and the perimeter of the segment of a circle. In the previous videos, I explained that perimeter is the borderline of any given shape. So the perimeter of a circle is the same thing as the circumference of a circle. And the formula is 2 pi r. 2 pi r. I want us to observe this sector. We want to find the perimeter of the sector, and we have said perimeter is the borderline. So this is the borderline of this sector. So the perimeter will be L plus R plus R. That means L plus 2R. L plus 2R. But we know that the L is the length of the arc. The length of the arc is a fraction of the circumference of a circle. I want you to recall that when we're looking for the area of the sector, it had the same formula as the area of a circle that is taken from. We simply multiplied by the fraction. So the same thing is applicable here. Since the length of the arc is a fraction of the length of the circle, it will have the same formula, which is 2 pi r. But because it is not a complete circle, it's a fraction, we multiply by the fraction. So if I want to write my formula properly, this part with theta over 360 multiplied by 2 pi r, then plus 2r. That is the formula. Of course, you could factorize the 2r, you could factorize it, and the remaining thing you have there will be theta over 360 pi plus 1. You could also write the formula like that. Now, to find the perimeter of the segment of a circle, the definition has not changed. The borderline, we just sum up the borderline, and that is the perimeter. Now, to find the perimeter, I could write the perimeter to be C plus L. We know what L is. We just calculated it. Obviously, we know that it is C plus L. Theta over 360, 2 pi r. But where's our theta? That means we need to do a construction here and get a theta. So if I draw the radius and draw the second radius, the angle here is the theta. How do I calculate my C? If I have this kind of triangle and I have this as R, I have this as R, I could use cosine rule to find my C. And I could also decide to divide this into two equal parts. So whatever angle I have here, half of it will be here. And I can also use my trig ratio formula to find this. And once I get this part, I multiply by 2. That will give me the whole of this. So the formula is C plus L. We have learned that if you want to find the perimeter of a circle is the same thing as the circumference of a circle, and the formula is 2 pi r. To find the perimeter of the sector of a circle, the formula is L plus 2r, L plus 2r, where the L is the length of the arc, and we have 2r, which you could factorize out and have the formula written like this. And finally, to find the perimeter of the segment of a circle, the formula is simply C, which happens to be the chord, plus L, which happens to be the length of the arc. You just add up, and whatever you have is your answer. Thank you for viewing my channel, and please do not forget to click like and subscribe to our YouTube channel so that you can get more information on any other topic. Thank you and God bless.